I thought I would maybe just demonstrate my tic-tac-toe code. Okay, so you could see how my stuff works, and if you have questions about how your things need to work or whatever, I'm happy to try to handle those. We'll maybe spend just kind of the first 5 to 8 minutes doing that, and then we'll get into our lesson for the day. Okay, so here, so I'm not going to let you see the code that I've written, but I've sourced it. Okay, and you can kind of see the functions that I have written. So I think maybe one that's a little bit one that I didn't define was prompt user, but basically I've got kind of who we have. So I'm going to just run the function play. All right. So we'll start off. We'll do a 2-player example. Okay. All right. So where should X play? We'll say, all right, X will play at spot 5. Where does O want to play? Where do you guys want to play? 7. Okay. And then so naturally I will play. I don't know. I'll play at 1. Okay. So you guys will play at 2. 9. Okay. Well, all right. Let's just say you make a mistake, right? And you do play at 2. Okay. And or I played at 2. Okay. All right. Well, now I've got you. And then so you play at 3, and then I play at 8. And then it says I win. Okay. All right. Or and then here we'll do play again. Okay. We'll say how many human players. We'll say 1, and then it's asking me should the computer play first or second, and I'll say the computer can play second, and then so here I'll play. I'll play at spot 1. The computer plays at spot 5. Let's see. So I'll try to go immediately for a win. I'll play at 2. The computer blocks me at spot 3. It says O plays 3. And then so I'll play at 7. Okay. And then the computer goes there. So well, I'll play at 8. Okay. And at 8, the computer goes to 6 and wins. Okay, so this is that's that. We can just kind of check how a few things work. So here I'll create a state of 9 NAs, and so if I say display the state, it just creates a blank board. Here I'll do update. If I do update state and I'll say X plays in spot 3, then for me it just does this, and then so if I want to display that, then I get the thing there. Okay. I don't know, that's kind of a hint, I guess. Questions on what needs to happen there? So people have been asking, how do I get the thing to update the state? Well, if you just run update, so if you notice my state, the state hasn't actually changed. So if I want to do update state, I would have to do something like this, right? And so now state has the update, and then I can display state here. Okay, and then I can just run computer turn on the state. Okay, and here it says the computer will turn play in spot 5. Okay, and so so if computer turn will be spot 5, then I would have to run update state O at spot 5, okay, and we have that, and then I would have to store that as my new state, and then if I can display that, and then here I have this, okay. and then it would technically be my turn, right? But I guess we could have we could ask computer turn on our current state. So if it was technically if it's a computer turn, then that means it's X's turn, and so X would go to this is not the smartest play, but it says it'll play an 8 or something like that. Okay, so you don't have to don't worry about trying to program your thing to play optimally. Okay, I only want it to successfully block and successfully win. Okay, so if it has the opportunity to win, it's going to play to win, and if it can't win and it has an opportunity to block, then it will block, and if it can neither win nor block in the next turn, then we'll just let it play wherever it wants to play. That's fine. Okay, you don't have to. I know. I don't know if it was your TA or the other TA that talked about a minimax algorithm. That's an option, but you don't worry about it. Okay. Okay. Are there any questions on this? Yes.
So for computer turn, it only can return like the index one.
Well, that's how I implemented it. For me, the computer turn is going to return just the number. I suppose if you want to have a different system to do things, I was able, within my play function, I was able to keep track of who is X and who is O, and thus the computer will figure out where to play based on that, without the need to pass values in here. Basically, if we show, so the way I did it was X always plays first. Okay, so if I show it this and we see an X, one X and one O, we know it's X's turn, right? And then if we show it this state and we just see one X, then the computer can deduce that it's O's turn, type of thing, if we know that X always plays first. So, yeah.
Okay, so the computer turn doesn't have to actually display the board again, or like turn out a vector, but you can make it just turn out a vector of like where it's placed. Is that okay?
So again, yeah, the way you implement it is a little bit different, might be different from me. The way I chose was, I kept everything separate. Computer turn simply just tells me where the computer's going to turn. Update updates the board, and display does the display. Okay, and within the play function, I kind of had it check, go through, and keep track of the other things that need to be kept track of. So I'm hoping, at least this little demo here of play. Here, I'll just do one more instance of play. We'll do 2 human players. We'll have X play in 1, O will play in 5, X will play in 2, O will play 3, and then X will play 7, and then O will play 4, and then X will play 6, and then so now we're kind of stuck. O will play 8, and X plays 9, and then here it tells me that the game ended in a draw. Okay, so that's what we have. Okay, but so here it, every time I play, or at least for prompting the user, it displays the current state of the board, and then the user inputs where they want to play, and it shows what the board looks like after updating it as such. Okay, is that all right? Okay, so I'm gonna put a break in the video here.